This is our experimental setup for measuring Planck's constant using blackbody radiation. It consists of the main unit, which is this one, housing the DC power supply, which can be controlled by the fine and the coarse knobs given over here. It has a DC voltmeter and a DC milliammeter for measuring the filament voltage and the filament current. We have a DC microammeter over here having dual range 20 microampere and 200 microampere. This is used for measuring the photocurrent. The two terminals over here are connected to the terminals given over here, which are basically the output of the photodetector. The tungsten filament bulb is housed in this cylindrical box over here. This is the filter holder, and this is our photodetector. Now a scale is given over here for accurate measurement of the distance of the photodetector from the bulb. We have been given two filters. One is a yellow filter and other is the red filter, along with jacks. And a very detailed manual is given, which consists of sample readings and calculations. Before starting the experiment, we have to connect the socket from the bulb to the back of the main unit, as shown here. Connect these two terminals with the help of the jacks. Make sure that the knobs are turned to the minimum position before we switch on the kit. For the first part of the experiment, we need to find out the voltage and the current for the condition where the bulb just starts to emit a dull red glow. So for that, we will switch this on. We will change the voltage with the help of this knob given over here, and we will look through. As you can see, there is a dull red glow which is being emitted from the tungsten of the bulb. This corresponds to 1.46 volt, 4546 volt, and the current is around 588 milliampere. Let's take a quick look at the manual. It has the detailed apparatus, the theory used, along with all the formulas, the graphs, the working formula, the schematic circuit diagram, and also the circuit connection. The procedure has been given in detail. So we are at the first part, that is finding the resistance at the draper point. So this is a sample table given over here. So here we have got voltage as 1.47, current is 539 milliampere, and from there we calculate the RG. We can take 3 readings in order to get a mean value of RG. For the next part of the experiment, we will set the photodetector at a distance of say around 8 centimeter or 10 centimeter. We will now change the voltage in steps of 0.5 volt or 1 volt up to 10 volt, as the bulb used is a 12 volt bulb. We'll note the filament current. We will also note the photocurrent, which is theta over here. And from this we'll calculate the RT, the value of RT by RG, where RG is given in the first table. From the theta value, we'll calculate log theta. And there are 2 ways in order to calculate the temperature, which I'll be explaining in a short while. Since no filter is used, the lambda over here is 6000 angstrom. So right now I've set it at 10 centimeter. There is no filter. I'll just close this one so that no light goes in. Make sure this is at the minimum position before starting. Now change the value in steps of either 0.5 volt or 1 volt and measure the current and the photocurrent. So initially no photocurrent is shown here because the voltage is very small. We can increase the voltage to get an appreciable amount of photocurrent. Change the toggle switch to the 20 microampere range so that we get accurate values. So like this. Keep changing the voltage and noting down the current and calculating as shown in the table. We can repeat the same thing by using a filter. Let's say we're using a red filter or a yellow filter. Note the distance where you have set the photodetector, and then note the voltage, the current and the photocurrent. So if this goes over range, change it to the 200 microampere range. There are two ways in order to calculate the temperature. The first one is using this formula. So we will find the value of the RR using the formula, and the RT is to be found from here, and for each value of RT we are going to calculate the temperature T in Kelvin. The second one is by using the table given over here. This table is between the temperature and the ratio of RT by Rg for a tungsten filament. We can consider the values of RT by Rg and the corresponding temperature we can find from this table. In both the cases, the results will be similar, so either one of the method can be used. From here we will calculate the slope, that is del log theta by del 1 by t, and from there the Planck's constant is calculated to be around 4 into 10 to the power of minus 34 joules second. This is by using the red filter, similar results, and this is the table for by using the yellow filter. So these are all sample tables given. The readings will definitely vary every time, but the result should be similar to the values given here. Switch off the kit after doing the experiment. Make sure these are to the minimum position. So this concludes our experiment for finding the Planck's constant using black body radiation. Thank you.
Please subscribe to our channel for more such videos. Thank you for watching.